Hi, I'm Paul Kintner from Ecotope. I'm here today to discuss the Ecosizer, an educational tool to help designers and manufacturers build appropriately sized and affordable central heat pump water heating systems using a new sizing methodology. So why domestic hot water? Well, the domestic hot water load can be about 25% of the total load in multifamily buildings. Heat pump water heaters, though, can help reduce the energy use by 65%, making room for other electrical loads on the grid like cars. They also operate well as thermal batteries, so you can move that load that you see in the evening associated with large hot water draws when everyone gets home and takes their showers, and try and heat up all that water preemptively when the sun is shining during the day. Domestic hot water load can be split into two other loads as well. The domestic hot water heating load, the energy the occupants are using at the taps, and the temperature maintenance load. This is the energy associated with keeping the hot water distribution piping hot. So the person at the very end of the pipes doesn't have to wait 10 minutes for their hot water. Studies have shown that this load can be on average 30% of the total water heating load, or 10% of the total building energy use. And most of this energy is just kind of being wasted. People should be working to minimize this load. And we should also be using efficient equipment to deal with this load. And there's really only one way engineers deal with this load, and that's by bringing it back to the water heating plant to be heated up with our water heating equipment. But hot water circulation can create issues with heat pump water heater operation if they're not designed appropriately. And properly addressing this requires smart design, which goes hand in hand with how the systems are sized. The older sizing methodology, if people used it, would have been ASHRAE, which when people think about sizing these systems like boilers can lead to over double what is needed, creating a system that's very expensive and results in an unstable system and shortened lifespan of the equipment due to short cycling, which only adds into maintenance costs as well. These two systems shown here serve buildings with a similar number of units, but one operates with 1/10 of the heating capacity and a smart design, away from thinking about these systems as boilers. At Ecotope, what we've been doing is sizing systems by minimizing the heat pump capacity, which can help minimize costs. At Ecotope, we've primarily worked with single-pass heat pump water heating equipment. These are most efficient and operational at making cold water hot. So it's important to separate the temperature maintenance load from the primary single-pass heat pump water heaters. In the Ecosizer, we've standard two options for doing this. A parallel loop configuration, where the primary plant is completely separated from the temperature maintenance load. And the temperature maintenance load is covered by a multi-pass heat pump water heater, which is taking the recirc return water at about 115 and doing a single lift up to about 125 for the supply water. The other schematic is a swing tank, where the temperature maintenance load is covered by an electric resistance heater and the primary heat pump water heaters. When a domestic hot water draw occurs, hot water is taken from the primary storage to feed the swing tank, which makes up some of the temperature maintenance load. Some preliminary studies suggest that about 50% of the temperature maintenance load can be covered by the primary heat pump water heaters for an average market rate building. If we standardize these design approaches, this makes the job of modelers easier and will help designers and engineers to deliver reliable results and consistent sizing across their projects. At a high level, what the tool does is take user inputs for the peak hot water demand day, and then we recommend a maximum compressor runtime of 16 hours per day. Together, these can define the hot water generation rate, shown by the orange line here. The old ASHRAE method would size a system to a 2 or 3 hour peak load and put the whole thing in storage. Our modified methodology accounts for the fact that equipment can generate hot water while it is being used by building occupants and size the volume based around the green area in the graph shown here. Even if the sizes come out comparable, what we're interested in seeing is that we're sizing these systems for the correct reasons. This method could easily be applied for load shifting, if we're assuming that the generation rate goes to 0 during certain hours of the day. And then what users get out of the tool is a recommended size for the primary system and the temperature maintenance system based on the schematic, and a trade-off curve between the primary heating capacity and the primary tank volume that accounts for this temperature maintenance load. Users can use these systems to size a system for their individual cases. And all of this software that does the sizing calculations is open source and available for anybody. In fact, Mitsubishi has already expressed interest in it for their systems. Thank you.